Welcome back to my channel. So for this video I will start with Physics from 5 KSSM on the first chapter, Forces and Motion 2. So the first part that I want to discuss in this video is 1.1 Resultant Force Part 1. So for this part there are two learning standards. The first one is define resultant force. The second one is determine resultant force. Before we continue with the resultant force, I hope you still remember what we have discussed in Chapter 2, Form 4 KSSM about forces and motion 1. So let's look at the definition for force. What is force? Force is simply a push or a pull. So the action of pushing or pulling, meaning you are applying force on the object. A force is always exerted by an object and always acts on another object. As a case of action and reaction is the weight and normal reaction force. Look at this person pushing a trolley. So the trolley will move. So there is force act on the trolley. Forces sometimes act on the object more than one. For the case of more than one force act on the objects, the forces can be either balanced or unbalanced. So in this topic, we want to discuss what happened to the object when the forces act on the object are balanced or unbalanced. Okay. Now we want to define what is resultant force. Before that, let's look at this situation. When two forces of the same magnitude acting in opposite directions are applied on a stationary object, the object remains at rest. Look at this one, tug of war competition, pertandingan tarik tali. There are two participants, A and B. Participant A apply force or pulling force Fa. Participant B apply pulling force Fb. As you can see, there's a yellow flag here. This one will show that whether which side will move more than the other side by refer to this yellow flag. So the reference line is the white line here. If the yellow flag stay here, meaning there's no movement, they are balanced. Okay, so from here we can say the force that act Fa is equals to Fb. Example, force applied by A is 50 Newton, B is also 50 Newton. So Fa equals to Fb. So in this case, you can see the two participants does not move. They are pulling, but they are not moving. So they remain at rest. So in this case, Fa is balanced by Fb. Or we can say forces are balanced. So when forces are balanced, the resultant force is 0. Or the net force is 0. Okay, second situation. Assuming two opposing forces have different magnitudes, the object will move in the direction of larger force. So participant B is pulling with greater force 80 Newton compared to participant A just pulled by 30 Newton. So you can see the yellow flag now move towards participant B. Looks like participant B won the tug of war competition. So in this case, Fa is smaller than Fb. So the forces are not balanced. Fb greater than Fa. So this one will produce resultant force to the right. So the net force to the right is equals to 80 minus 30 or 50 Newton towards right. Okay. So you can see from here, the object will move in the direction of larger force. Okay, so the resultant force is the single force that represents the vector sum of two or more forces acting on the object. The meaning of vector sum means when you total the force, you need to consider direction. For example, we assume to the right is positive and left is negative. So when you total up or you sum up the forces that act on the object, for the positive direction, you put positive sign. For the negative direction, you put negative sign. Let's look at some more example on this. Okay, let's say we want to determine a resultant force. Situation 1, two forces acting on the object in the same direction. Parallel in same direction. Direction dia sama, so kedua-duanya ke sebelah kanan. Okay, so you have two forces, 6 Newton and 8 Newton. Assume that force to the right is positive. Kita anggapkan yang sebelah kanan sebagai positif. Magnitude of resultant force. How to calculate the resultant force just now? Vector sum of the forces that act on the object. Hasil tambah vector. Meaning need to look at direction. Kena ambil kira arah atau direction. So direction to the right is positive. Thus net force or resultant force F equals to 6 plus 8. Both positive because both directed to the right. So F equals 6 plus 8 equals 14 Newton. Okay, final answer also positive, meaning resultant force is towards the right. Okay, so resultant force we can write down its magnitude and direction. So resultant force is 40 Newton to the right. Situation 2, two forces also parallel but opposite direction. So you can see 8 Newton to the left, 6 Newton to the right. So assume that force to the right is positive. So resultant force equals to vector sum. So 8 must put negative sign because left. So negative 8 plus 6, you get negative 2 Newton. So resultant force negative. This one shows that resultant force is to the left. Okay, so magnitude of resultant force 2 Newton, direction to left. Okay, that's why we get negative sign here. Okay, next situation. The two forces acting on the object perpendicular to each other, 90 degrees to each other, 6 Newton, 8 Newton. So there's a step to solve this one. This one is by using mathematical operation, but before that we need to sketch a vector triangle. Okay, in order to get a vector triangle, suggestion is you can see these two forces already form two sides of a rectangle. So what you do, you just complete it to become a rectangle. Okay, so you can see this one already form a rectangle. Next step is, so you can see the black dot here. The black dot actually represent the object or the starting point where you draw the forces. So normally this one is the object. Okay, so now the next step is, once you already have a rectangle, you draw a diagonal line starting from the object. Not this one, should be this one, from the object. So all forces act on the object. So this one will become resultant force. Okay, so as you can see here, this part will form a right angle triangle. So we are going to use mathematical operation to solve this question. We want to find F. So this side is also 6 Newton, this side. Okay, angle between theta. Okay, so let's say we draw out this part, half of the triangle, this part. So it formed like this. Okay, this side is 8 Newton, 6 Newton. This is resultant force, and angle here is theta. We want to determine the resultant force because of right angle triangle, so straight away we use the Pythagoras theorem. F equals to square root of 6 squared plus 8 squared. So we get F equals to 10 Newton, or you can see clearly 6, 8, here must be 10. Okay, so you have the net force or resultant force 10 Newton. So now we want to determine direction. Direction always use angle here. Angle theta. So meaning angle theta from 8 Newton. So how to find theta? We have all the side, but the value of f we calculate from here, okay, by using mathematical operation. Normally we don't use the calculated value again, because if this part is wrong, then your next answer also will be wrong. Now we use what given. Okay, so we use tangent. Opposite divide adjacent. Okay, so tangent theta equals to 6 divided by 8, or 0.75. Use calculator to determine theta. So you get 36.9. So use arctan, arctangent. Okay, 36.9 degrees. So we have, if we draw, it's just like this. This is the resultant force, this is direction. So you can write again, resultant force is 10 Newton in the direction of 36.9 degrees from 8 Newton. So this is the complete way to write resultant force, because resultant force is a vector quantity. There must be magnitude and direction. Okay, situation 4. Two forces acting on the object in direction that are not perpendicular to each other. So suggested method to use is scale drawing method. Kaedah lukisan. Okay, so this, let's say we have these two forces, F1 and F2. I use example to explain this one. So let's say F1 is 100 Newton, F2 is 100 Newton. Angle between the two forces 60 degrees. Okay, the first scale drawing method is triangle method. We want to draw the triangle to represent the forces that act on the object. Okay, so this point is the object. We are going to use this point as a starting point. Okay, the first step, choose suitable scale. How to choose suitable scale? Look at the magnitude of force given. Okay, and you must check the space given in the question paper, whether it is enough space or not if you draw the triangle. For this 100 Newton, I choose 1 cm, 20 cm. So that the force, when I draw, it becomes 100 divided by 20, 5 cm. Okay, so meaning F1 5 cm, F2 5 cm. So there's enough space given to draw. So my advice is, for during the exam for physics, you better get ready with all the instrument or apparatus. Something like, you must have a ruler, of course, pencil, compasses, and protractor. Okay, if not, you cannot complete this method. Okay, you have choose the scale. Now we want to start drawing. Draw the first force followed by the second one. Normally the first one we choose the one that horizontal or vertical. So in this case I will choose F1. Okay, start from this point. So we can start drawing. Start from this point. This is the starting point. Measure accurately 5 centimeter. Then you draw F1. Label. Okay. Next. End of F1, we are going to continue drawing F2. It's just like you shift the position of F2 to here. Pindahkan F2 ke sebelah sini. But angle must be correct. Okay, first you can draw one reference line. Okay, and then measure 60 degrees. Then you draw the second force. Okay, you can see from here it looks like you bring this one to here. Okay, parallel line. So angle here must be 60, or alpha. Okay, now you have two sides of a triangle. Next step, complete the triangle by drawing the third side. We just join initial and final here. So this one will become resultant force. So how to determine the resultant force, the value or magnitude? Just now you already measure accurately, F1, F2. So in order to get resultant force, you also measure the length of the line. Okay, let's say you get 8.7 centimeter. So this is not yet the answer. So 8.7 centimeter multiply with 20 cm. So you will get 174 Newton. This is the magnitude atau nilai dia. Direction, how to get direction? Use protractor, measure angle theta. Don't just guess, you need to measure accurately because everything just now we measure accurately. So theta, measure using protractor. Let's say we get 30 degrees. Okay, you must try to draw and then you can check 30 degrees from F1 or 100 Newton. Okay, so for this type of question scale drawing, sometimes the final answer, the range of answer will be given. Because when using ruler, sometimes maybe some student they will get 8.6 centimeter. Maybe the other student 8.8 centimeter. Meaning in the range of plus minus 0.1 centimeter. Okay, and direction, sometimes got a 29 degrees, sometimes 31 degrees. So there is a range of answer. Okay, so this one we call it triangle method. Okay, the second method for the same case of forces not perpendicular to each other. So we also have another drawing method, parallelogram method. Okay, the same thing. First, choose correct scale, 1 cm to 20 cm. Draw two forces to form two adjacent sides of parallelogram. So for this one, as you can see from the actual diagram given here, F1 and F2 already form two sides of a parallelogram. So what you do, you just copy. Okay, copy this diagram, but you need to measure everything accurately. For example, you start with F1. Okay, and then angle here must be 60 degrees. You draw F2, another 5 cm. Okay, this one is F2, F1, F2. Then you can use compasses to complete it to become a parallelogram. So this is the parallelogram that form. How to get the value of resultant force? Just now this one is starting point. Okay, so draw diagonal line from that starting point. Okay, so you can see the blue line here represent resultant force. Okay, so how to get that value? Same as triangle method. Use ruler, measure length of the blue line or diagonal line. So you should get the same value. So you get 8.7 centimeter. So 8.7 times 20, you get 174 Newton. Direction also same. You can use this one, theta. Okay, direction is 30 degrees from 100 Newton or F1. So you can try to draw first this one. So for triangle method and parallelogram method, both should get the same answer. Okay. Okay, just now we used a mathematical operation by sketching a triangle of forces or scale drawing method. So actually we can use this vector force table kit to find a resultant force for the two non-parallel forces. Okay, so you can find this in the lab. Okay, the magnitude and direction of two forces that are at angle with each other can be determined by practical means using vector force table kit. So there are three pulleys here. Sometimes got four. Okay, let's say we have pulley A, B, and C. So you can see at the table of the table kit here, you can see they label it with angle. Okay, there's a line. Okay, or there is a mark for 0 degrees Celsius and also 360 degrees. And then you can change the angle by placing the pulley at certain angle. Okay, so we have three pulley. So now pulley C actually is the third forces that will balance A and B. Okay, or we can say C will act as a resultant force. Okay, we have three situation here. Pulley A 150 gram. Okay, pulley B also 150 gram, but pulley A is 20 degrees position, meaning from the 0 mark 20 we put the pulley A. Okay, and then pulley B 340 degrees, meaning from the 0 mark you also, let's say you for the angle 20 you measure is anti-clockwise. For the 340 means clockwise 20, so that one will become 340. So the angle between actually is 40 degrees for this one. Okay, okay, the second one, the angle between is 80 degrees. The third one, the angle between is 120 degrees. Okay, so how we use this vector force table kit, you can watch this video. So we use it for addition of force. You can see this is the table kit, the vector table kit. So we use slotted weights. Okay, how to add the force? So first you can attach the pulley here to the side of the table. Okay, and then you can hang load. Let's say we have two pulley A and B here. So let's say this one is C. So you must keep adding the mass, so that finally you can see the mass that you add will cause the load to balance the other two loads hang at A and B. Okay, so you can repeat with different masses of load. Let's say we have this one is A, this one is B, and this one is C. Okay, this is only what suggestion. You can use the table here as reference for the value of mass A and B. Okay, so what you do then, you need to adjust the pulley C, so that pulley C will balance. Okay, A and B. How to make it balance? You can check the ring here. The ring must be at center, thus not touching the cylinder here at the center. So once the ring is balanced, meaning forces are balanced. Okay, so the mass of load that added to the pulley C, we can determine and record here, and then you can calculate the force applied by using the formula force equals to weight equals to mg. So in this case, G is G that used here is 10 meter second to the power negative 2. Okay. So you see from here the force applied for pulley C actually represent resultant force for force A and force B. Okay. So you can try it. For example, we have this sample of answer. Let's say for the first one, 20 degrees position for A and 340 degrees for position of B. So we get mass 280 gram. So the force applied equals to 2.8 Newton. Okay. And then next one, we get 230 gram. So the force applied is 2.3 Newton. Okay. And the last one, the mass that we recorded is 150 gram. So the force applied is 1.5 Newton. Okay, so this is how this vector force table kit can be used to determine resultant force for two forces which are not parallel to each other. Okay, let's discuss some of the question here. What is direction of resultant force of the two forces that act on the metal ring through pulley A and B? So in the direction of force on metal ring through pulley C. Okay, so we just look at direction here of the metal of the pulley C. Okay, so that one will represent direction of force or resultant force. Number 2, Y is magnitude of the force acting on the metal ring through pulley C equal to magnitude of resultant force. So the metal ring position at the center shows that forces are balanced. Okay, that's the reason why force acting on metal ring pulley C equals to resultant force. Okay. Number 3, how does magnitude of resultant force change when angle between two forces increases? So magnitude resultant force decreases as less mass at pulley C required to position the ring at the center. So you can see the greater the angle between, the lesser the force required to balance the two forces. Okay, so this one actually can be proved by calculation. So for this part, I will stop here. I will continue in next video a resultant force part 2, where I will discuss on problem solving. Okay, that's all for now. Bye.